Hi there, good afternoon.
Good afternoon.
Oh, wow. Okay, so thank you very much for coming to this session. So today we're going to talk to you about creating and managing custom images with the new Virtual Machine Image Builder service. Notice there was a slight change of name between when this session was submitted to what it is now. It's still the same thing. So my name's Daniel Sol. I'm a program manager in the Azure Compute group. Specifically, I actually work in a Linux team. I'm joined here by my colleague.
I'm Paul Meyer. I'm a principal dev in the Azure Linux team, and I'm the dev lead on this project.
Okay, thank you. So if you don't like it, you can actually tell Paul straight away and berate him, and he'll add it to the backlog.
Exactly.
Okay, so we're going to talk about the image builder and what it is. We'll talk about the service. We'll talk about some of the management, the scale, the security, and then we'll see how it can integrate with CI/CD and what our roadmap is. There's a couple of things I need to make you aware. This is a Linux-first service, and the reason is for that is because creating custom images for Linux is somewhat more complex and has more steps than creating custom images for Windows. That being said, having this service support the Windows OS is on our roadmap. So even if you don't actually create Linux images, you're very welcome to stay and actually see what our roadmap and our vision is and actually give us feedback. I had a small session yesterday, and I already had feedback on what we should be doing for Windows, and we'd welcome that. Secondly, this is just gone private preview today. If you actually look at the Azure blog site, you'll see it there. This is very, very early on in the release process. So you can't actually see it publicly available. There's no public docs, but we'd happily invite you to the private preview at the end of this. So who here today actually creates images, custom images? Okay, wow, a lot of you. Who here specifically creates them for Linux? Okay, quite a few. And the rest Windows, I assume. All right, awesome. So when we think about creating custom images, why do people do it? We have plenty of images in the Azure Marketplace, vanilla RS images. Why do people do it? There's a few reasons. One of them could be because people would like their operating system pre-configured with the application already baked in. And then as soon as the VM boots, the VM can immediately start taking the application load. Second, they could be creating custom images because they want to have a golden image that in their particular organization that supports compliance and governance settings. Additionally, it could be because of licensing requirements. For argument's sake, we have in the Azure Gallery, we have Red Hat images. These are pay-as-you-go license images. If you wish to use your own Red Hat subscription with your eligible unused licenses, what you'd need to do is essentially build a custom image from a Red Hat ISO. So what does it actually take to create a custom image? It takes a variety of tools. You need to stand up some infrastructure. You need to go and find some tools that could potentially actually build this for you. So tools like Packer, Ansible, Chef, potentially, for some further configuration. And essentially, you need to know then how to actually configure the operating system. If we think about what it would take to create a Red Hat, take a Red Hat ISO and then actually convert that to a bootable Azure VHD, there's a page here on the Azure site on how to do that. And there's a lot of instructions here on how to do that. Essentially, you're going to need maybe Hyper-V to do that.
Look how tiny the scroll bar is, man.
So there's plenty of instructions. And when I actually sort of think about creating these particular images and what it takes, it's almost like you're a chef and you've got this very complex recipe with some interchangeable ingredients. And then you need to know, right, what ingredients do I want? And then how am I going to make the perfect pie at the end of this? And if you get image creation or creating custom images wrong, at worst, the image may, or at best, the image may slowly provision or slowly start up, or at worst, it may just never actually start up at all. And it involves a lot of time. So today, we're actually announcing the private preview of the Azure Image Builder service. And what is this? Essentially, what you can do with the service, you can define your custom image in a template. You simply pass it to the service, and then the service will basically stand up the infrastructure and then build you a custom bootable image at the end of that. For private preview, we're targeting these scenarios. The ability to migrate your existing image customization pipeline to Azure. Second, migrating your Red Hat subscriptions to Azure. So the Image Builder service will allow you to ingest a Red Hat ISO and produce a bootable Azure VHD at the end of it. And then image management right at the end of it. Images aren't just for Christmas, they're for life. You have to maintain them. So things like versioning, replicating them to different regions, updating them. So here's actually the Azure Image Builder service from a 50,000 feet level, what it actually looks like. And it's made up of three key components: source, customize, and distribute. So now I'm going to hand over to Paul to detail it more.
Yeah, so who here builds their custom images using Packer? Can you see some hands? Oh, that's less than I thought it would. So Packer is a beautiful tool by HashiCorp that helps you basically do this as a client tool. Although as a client tool, it's still, as we noticed from feedback from our customers, still quite a bit of work to do that. So we decided to build our service around some of the same concepts and actually use the tool inside our service as well. So for example, when you say, I want to build a RHEL VM from my own ISO, we actually use Packer on the inside to take the RHEL ISO and boot a nested virtualization machine with that ISO and install Red Hat using a Kickstart file. And that's basically how we do that on the inside. Similarly, for customizing using shell scripts, we use Packer to basically boot a VM on Azure, run your shell script, and capture the image. We're looking to use Packer in a lot of more places, and probably also extend Packer to get more scenarios captured. But that's basically how it works, a little bit closer up than 50,000 feet.
So what Paul mentioned was, for source, we allow the ingestion of two types currently. For private preview, what you can do is you can pass in a link to a RHEL ISO. So you'd go to the Red Hat Download Center, and you go and copy and paste in the ISO and the checksum, and then what happens is the Azure VM Image Builder will ingest that ISO for you. Second, we also support the ingestion of Azure Linux vanilla images, so the ones that are on the marketplace. Currently for private preview, we're only supporting 1804 and 1604 Ubuntu images. We will increase this, but this is what we've tested with so far. Thirdly, one of the things that we've got on our backlog and we want to get to quite soon is the ability for the image building service to actually ingest existing custom images that you may already have. So once you already have defined what your source is, the next section is customization. You can have multiple customizations in here. Currently, we support shell scripts, and essentially what you do is you just say, right, here's the shell script I want you to download and run, and the image building service will go and pull that down for you. You can have multiple shell scripts, and the image building service will essentially run them sequentially, and if there's any errors with them, it'll spit out the error and it'll stop the pipeline. Lastly, you have the distribution. So you can either distribute to a managed image or a shared image gallery. Who here's heard of the shared image gallery? Okay, all right, a few of you. Has everyone heard of managed images? Okay, all right, quite a few of you. So essentially we support that. I'm actually going to talk more about the shared image gallery because there's a lot of goodness here. We also have the PM team here as well, so they can answer questions on that too. So let's have a look at a bit more detail on how the service actually works. What you'll see is to the left, you have this configuration template. and I'm going to show you this in a minute on the screen in code. It has the properties on there, so it will have the source, the customize, and the distribute. Once you've got your template ready, you need to actually submit this into the service. And what happens at this point is the service ingests it, and if everything is correct, it will then save that as an image template artifact. This is actually an object that you will see in your subscriptions within a resource group. After that's completed successfully, you then invoke run on that particular image template. At that point, the image builder will then stand up the resources needed to actually create your image. Once that's completed, it will then spit the image out either to a managed image or to a shared image gallery of your choice in your subscription. So management. The key thing to point out is that the image builder is actually a first-party resource in Azure, Microsoft Virtual Machine images. So you will see an ARM template and you will see this resource referenced in there. As I mentioned, you create your image template artifact first, you invoke the image builder, and then you distribute it to the regions of your choice. And it also has the capability of versioning. So let's jump to the demo. So what I'm going to show you is, I'm going to show you some image templates examples. This is a public GitHub repo, and what I've got two examples. So I'm going to start with the Ubuntu example, the platform image example. So here you can see the resource type, and then now you can actually see the properties of the image template artifact. So you can see here for the source, I've got a platform image. I'm now referencing publisher offer SKU, a bit like you do with creating a VM today. You define which image you want it to be. Next, you have customize. So if you actually notice, customize is an array. So I can, as mentioned, I can have multiple shell customizers in here. I can pass in multiple scripts. The key thing here to point out is that the actual image builder will need access to your scripts, so it will need to be able to get to them externally. Lastly here, you have distribute. Again, distribute is an array. I can actually distribute to multiple targets. So in this example here, my type I'm exporting to is a managed image. And so essentially, I pass it a managed image ID, which I get from the Azure portal or through CLI. I'll show you an example of that in a minute. I specify the region where I want the image distributed to. I specify the image name, named run output, and then I can apply some tags to it as well. A slightly different example of a template is actually using the Red Hat, or sorry, using the ISO type. And here I can support the ingestion of a Red Hat ISO. We only support the ingestion of RHEL 7.3 to 7.5 inclusive of ISOs. You can't import any other ISOs. And essentially, like I mentioned, you just go to Red Hat, you go to the download center, and you look up the binary DVD and right-click, copy the link address, and then just paste it back into that template. So let's have a look in Visual Studio Code. So what I'm going to do is now, live, I'm going to create an image template. And essentially, I'm just using an ARM deployment template and parameters file. And in this particular parameters file, what you can see is I'm just using an Ubuntu Server 1804 image. I've got this customized script path here. So I'm referencing a tiny script that I have on my repository. It's really not that interesting. I lack creativity. And then I've specifying here, I've got a gallery image ID and an image resource group ID, and managed image name and shared gallery image. Now, for this particular example, I've actually got two distribution targets. I'm referencing a template in what's it called? In GitHub, and you can see the template here that I'm referencing. And the template is pretty similar to what I showed you before. It's just heavily parameterized. And then down here in the distribution, you can see I've got a shared image type and I've got a managed image type. So I'm actually distributing to two targets, essentially. So what I'm going to do is I'm now going to run this.
So while Dan runs this, you might have seen that the API shape is still pretty generic. It says ISO, it doesn't say Red Hat ISO or something like that. The idea is that we want to build this with quality from the start, so we only allow images that we've tested and that we know work well. The API shape is generic because our backlog has many more other distros and other sources and also other customizers and other targets that we want to add later, and so we don't want to paint ourselves in a corner by naming things one way or the other. So that's kind of a little bit of the background there.
Okay. So this is actually creating at the moment. It doesn't take that long. What I can actually do is I can use a CLI command. Oh, why is that not running? Image name. Is that not working? 1 second. Oh, sorry, got the. So I'm referencing the wrong name. Okay, let's just go back.
That's always cool about live demos, right?
Sorry, 1 minute. Oh, this one.
You might see that we are using the generic resource command set in the CLI because we're still so early in the development stage that we haven't generated SDKs yet. So there's also no CLI support yet. We're obviously committed to bringing that out very soon, but it's all very early right now.
Okay, so what you've just seen is now we've actually gone ahead and we've created the image template. What you can do is when the image template is actually being created, you can check the status. And the way that actually happens is you pass this generic command here, and essentially you're showing the status for this particular resource. So if I dump this out now, I have this image template name, and what you can see is the provisioning state is succeeded. That means this image template has now been ingested into the service, and you'll be able to see it in your resource group. Sometimes what you see is when it takes a bit longer, you will see a status of creating. Now, this happened pretty quickly. It probably took about 30 seconds. The ingestion of this particular image, because it's an Azure platform image, is pretty quick. If you were to actually be ingesting a rel ISO, it will take longer. It will probably take about 10 to 15 minutes to actually create the template artifact. The reason is for that is because when you actually copy the link from redhat.com, it's actually got a timebox SAS token. I think it's like 15, 20 minutes. So immediately when we actually go to create the template, we download the rel ISO into the service, and we also download the script files as well from the customize step. That way, if you want to create your image from that particular image template artifact, you can do so at any time, and we have all the resources available to us, such as the Red Hat ISO and all those scripts that are needed. So if I now look in my resource group, what I can do is I can dump out the resources that I have. And what you're going to see in just a second, you will see a bunch of, let's reduce that a bit. You will see a bunch of resources. And here, this is the image template name that I literally just created. And you can see the resource type is an image template. These get stored in your storage, in your resource group. And you can see that. So you can see I'm using the IB demo resource group. And you can see this particular image template being stored there. Now, just in case a bit later on I go and forget what the option was, I can actually dump out the image again if I need to, and I can see all the different settings that I actually put in there. So now, if I want to go and create that image, what I do is I run this, and what this is going to do it's actually referencing the image template artifact, and I'm posting a run action on it. So the image builder service will say, right, I'm going to use this template, and now I'm going to invoke the image creation pipeline. So let's clear that. Hold on. It's going to screw me over. Okay. Yeah, I've got the wrong template name. Okay, right. There we go. The reason it's failing is because I've got the wrong template name in there, so it hates me. So now it's going to sit there and it will run. It'll probably take about half an hour. So at this time, it's going to pull the image from the source, which is an Ubuntu platform image. It's then going to run the customization on this. And we can actually see the status of what's happening there. So if I dump this out. So this is now running. Let's have a look. So now what you can see is last run status. You can see that this is actually running, and you can see the substatus that it's building. That means it's in the first phase. So even if my session here actually gets disconnected, that doesn't make any difference. The image build will continue to run in the background. So what I can show you here, I can show you existing images that I've created. And this is just going to dump out some images. And you can see here, I have 05, 08. All these ones were created by the image builder. And these are managed images. If I actually wanted to create a VM from these, that's easy enough to do. All I need to do is pick on one of those particular images that I've built here. So I can take this one, number 05, and then I can use the AZ VM create, and then I can specify here using the image ID. So or the image resource ID. So if I go to the portal, let's show you what that looks like. So here it is. Here's the image that was created a bit earlier, and then here's the resource ID. Now I can use that resource ID, and then when I want to create a VM, I just reference that resource ID here as the image property. And I can now go and create that in the background. That should create absolutely fine. So I can show you that. Make sure that resource group's created. Yep, so I've created a resource group. So notice the resource group is different from where the image actually resides. So this one is in IB demo. That's where the image sits, where I'm actually creating a VM in a resource group called Ignite Image RG1. So now I can go and run that. And this will start running now in the background. Doing the donut thing. There you go. So that's running. So we're not going to wait for that. Okay. So I'm going to talk about the shared image gallery in just a second in a bit more detail about that particular output. But let's go back to the slides. So the shared image gallery. Shared image gallery is a really, really cool feature. This has just been made publicly. It's in public preview. It's in public preview right now. And essentially, the shared image gallery, you can think of it as the shared image gallery is a container. And inside that container, you have multiple image definitions. So in my case, I have Red Hat 7.3 images. I have Ubuntu 18.04 images. but you can call these anything you want. It could be production images, it could be test images, whatever. Within the image definition, you have a number of versions. And again, you can specify what versions you want these to be. And the real beauty of this is that these particular versions, they're first-party ARM resources, so you can RBAC them. You can actually share these particular versions of these images with other colleagues. So as long as your colleagues have Azure subscriptions that are under or subscribe to the same Active Directory tenant, then you can share these images with anybody in any other subscription. Another thing they also support is scale. So for each image version, I can actually say how many replicas I want of a particular version. Now, why would I want to do that? If you have a circumstance where maybe you're provisioning a VM scale set that maybe has 500 VMs inside the scale set, what you can find is that for a single managed image where you've only got essentially one replica of your particular image, you can get some storage throttling because essentially you're trying to stand up these 500 images, these 500 VMs, and they're all referencing this particular one image. Now, what you can do is here with the shared image gallery, you can actually say, look, I know I'm going to provision a large amount of VMs, maybe with this scale sets, so I'm going to create X amount of replicas to support that, and that will improve the provisioning performance or the time to start of those particular VMs. And lastly, per version, you can actually distribute your versions to different regions. So if we think about managed images, you create a managed image and say, you saw me in my example, I distributed or got the image builder to distribute a managed image to the West Central US data center. If I then wanted to go and do that in East US, I've then got to either tell image builder to go and distribute it there, or even without image builder, I'd have to copy a blob to that different data center in a different storage account and then recreate a managed image. You don't need to do that with shared image gallery. You just simply tell it the regions you want it to distribute to, and it will handle the rest, and it will handle the replication. So it's a really, really cool feature. I've got a reference at the end of this slide for another session for shared image gallery. And this slide here just actually calls out that individual images, even within an image definition, can be replicated to different regions. Every image that gets created is also subject to auditing. So I can actually see from the Azure portal, I can have a look in the activity log, and I can see who's actually gone and created that image. Like I also mentioned before, you can share these images or these image versions with your colleagues as long as you're in the same Active Directory tenants. And I've also mentioned here, you have image scale. A key thing to note is you can actually set the image scale per region. So if I have a region where I do all my testing in, I may only need one replica of a particular image version. However, for production, I may have multiple VM scale sets that I'm spinning up, and there I may want more replicas of a particular image. So let's have a look at some code. So first of all, I'm going to show you this piece of code here. What I'm doing is I'm dumping out the list of image definitions that I have in my shared image gallery. So let's go here. And essentially what I'm doing is I'm referencing my resource group and I'm referencing my image gallery. So I don't have a lot of creativity, so mine's called Dan IMG Gal. And then what you can see is here, I have a bunch of image definitions. So Red Hat 7.3, and then I've got down here Ubuntu 18.04. So think of these like the containers for the image versions. Now, if I have a look at the image versions, I can dump out the list. So now what I'm going to do is I'm going to dump out the list of image versions for my Ubuntu 18.04 image definition. And then what you're going to see is here, I've got multiple versions. These ones here, with these numbers, these have been created by the Azure VM image builder. This one here I created manually myself, but obviously you can do that too. Now, if I actually wanted to create a VM off that, the only slight difference is in the resource ID. So what you can see is here in this resource ID, I'm referencing my image gallery name. I'm referencing my image definition and my version, and then literally I can just create that. Now, what I'm going to show you where the images are currently located, in which regions. So let's clear that. And what you can see is here, for this particular image version, so I'm looking at image version 1.0, I'm looking in my Ubuntu 18.04 image definition. What you can see is here, I've got two target regions. I've got West Central US and South Central. Now, if I go back to the template, let's have a quick look on that one. Just go back to, sorry, 1 minute, where's he gone? When you're distributing to a shared image gallery with Azure VM Image Builder, the reason why I'm going into this level of detail is because what you can do is in the shared image gallery, within the Azure VM Image Builder template, you can specify which regions you want it to distribute it to. So you don't have to even worry about reference or modifying your shared image gallery version. This will just handle it all for you. Okay, so what I can do is here, if you notice, I've got these two target regions. What I can do is I can actually increase the number of regions. I can also change the replica counts as well if I needed to. And literally, all I need to do is that. I need to go and run this command. And what this is going to do, although it says create, essentially it's just going to update this particular image definition, the Ubuntu 18.04 image definition. It's going to update version 1. And what I'm going to do is I'm going to add East US 3 as the target. So let's go and do that. Now this is going to start running. Now what will happen in the background is the shared image gallery is going to start replicating that image over to East US. And then it's going to create three different replicas for me. And this will take a while to run. So what I can actually show you is I can show you the status of that running right now. And you can see that it's not going as quick as it should do. Kay, can you have a look at that? It's not even started the replication yet. But as you give it a bit of time, you will see the percentage of replication. So why am I actually going into all this level of detail? Essentially, the Azure Image Builder, VM Image Builder, distributes to shared image gallery. And inside the actual template, you can specify which regions you want to distribute this to. The whole point I'm trying to make is that you're not locked into just those regions. You can increase the number of replicas you have of a particular image, and you can also scale out to more regions, so you have this additional benefit and management around that. Okay, so now we'll let that run for a while. So, integration into existing CI/CD pipelines. How many of you here use CI/CD pipelines to create your images? Okay, all right, a few of you. So, if I'm in a position where I want to automate creating my images and I want to configure them, I can potentially integrate them into an existing pipeline, or I can possibly integrate the image builder into an existing pipeline I have. Now, what you've seen is so far, you've seen me just creating a single image. I'm running it through the command line interface. I've got some templates that it's referencing. However, if I wanted to do that at scale and I wanted to automate that, I'd most likely want to actually integrate that into an existing pipeline that I already have. Now, the other beauty is what you've seen is that the templates that are created for the image builder, I can actually just store them as code, and I can store them in a GitHub repository. So automatically, I then get versioning, I then get the auditing, I then get the change management. And these are some nice things that you can control and see what's being changed in your system. So, going forward, how can I actually integrate into an existing pipeline? So I spent some time putting this demo together. And essentially, what I've got here, I've got a GitHub repo. And inside that GitHub repo, I've got my application in there. And this is just some application that shows some music albums. It's written in Java. And then also inside there, I've got some Ansible configuration. I've also got some Terraform integration as well. And essentially, that all stays there. Then I'm using VSTS DevOps, and I'm using an Azure container instance. And essentially, what this does is this kicks off a build. And what the build does is essentially builds the code, and then it puts it onto a build share. The next stage is it then makes a call into the Azure VM Image Builder. Because we're storing the Azure VM Image Builder template configuration inside the repository, it can make a call directly to that endpoint and says, right, I want you to go and build this custom image with this bunch of customizations. And for this particular example, what I'm actually doing is I'm using a Rails 7.3 ISO, and I'm using a script that I created. And the script, basically, it just sets up some extras repository. It downloads Ansible, and then it runs a playbook underneath that. And I'll show you what that looks like. Once it's finished, it will then distribute that particular image to a managed image or a shared image gallery, either or, and then that completes. Once that's actually completed, it then goes and makes a call into Terraform, and then Terraform uses that managed image or shared image gallery version that was created, and then it will build up a whole VM scale set with a couple of VMs in there, an Azure load balancer, some networking, an IP address, and then that will all be brought up. Because the actual images that have been created already have the application deployed and the operating systems configured, immediately you will see the website become available. So let's actually have a look at that in some detail. Okay. So essentially here, I have my repository. The first thing you can see is I've got in here some folders. I've got Ansible, I've got Image Builder, I've got Terraform. Here I've got my application code in a minute, and you can see that there. But let's have a look at Image Builder. Essentially, I've got this deployment template, and this isn't very dissimilar to what I've already showed you before. This is just an ARM template. So let's widen that up. Here that I'm distributing it to a managed image and also the shared image gallery, and I'm distributing that to 2 regions. So it's pretty much similar to what I've already showed you. And here's some of the values or the parameters that are being passed in. A key point that this example that I'm showing you, this is not a best practice on how to use Visual VSTS, and also with the way I've got these parameters in, the secrets and parameters should be handled in a better, more secure fashion than what I'm using here. So anyhow, it's got these parameters. And then lastly, this is a sort of similar example of what I'm actually doing in the customization. So what happens is Image Builder downloads a customization script, and what you can see is here, because I'm using a RHEL ISO that I've downloaded from their download center, I need to register this with a subscription manager. What I'm then doing is I'm then setting up the extras repo, and then I'm installing Ansible. And then what I'm doing is I'm connecting to Azure Storage to download the build artifacts and the application. And then lastly, what I'm doing is I'm calling Ansible to actually then go and run the playbook. Lastly, because this is an image, just a custom image that I'm going to use multiple times, at this time I'm going to then unregister it from the subscription manager. So if I actually spend a bit of time and I look in Ansible, you can see here that I'm installing Java. I'm also installing Tomcat as well. It's setting up some firewall rules. And then lastly, down the end, it's actually deploying the sample app. So pretty straightforward stuff. Then a bit further down, I've also got some Terraform configuration. And then you can see here in main TF, I'm connecting to the Azure ARM provider. I'm creating a virtual network, subnet, and so on and so on. So there's a whole bunch of things that are happening.
So who here knows Terraform? Who uses Terraform? All right, so that's still quite a bit of people. So that's also a HashiCorp tool. It's meant for deploying multi-resource deployments to actually multiple clouds. You can target it to a specific cloud. And so that's what Dan's using here to deploy his app.
Cool. So essentially, that's the configuration. And essentially, I've got my infrastructure as code. I've got my customized image as code as well. And that's all ready to go. So I've got a build pipeline, and I've got my release pipeline. We're more interested in the release pipeline on how this all hangs together. So if we have a look in the actual pipeline, let's see what's going on in here. What I'm using here is a Azure Resource Group template, Resource Group deployment extension. And what this is doing, it's talking to my subscription, and it's going to create a deployment. And it's essentially just calling these it's calling the ARM template that was stored in that repository, and it's passing some parameters in there. Like I say, you could make this a lot better and a lot sexier and more secure, but it just gives you an idea of what's possible. You then invoke run on that particular template. So once the image template artifact has been created, it will then say, okay, now take this template and then go and essentially do the run action on it. That will then invoke Image Builder to build it, or build the image and distribute it to the managed image and the shared image gallery. Once that's finished, Terraform initialization will be called, and then next Terraform apply will be run. So that's a high level of how this works. Now, there's a lot of moving parts in here. There's lots of multiple technologies. I've mentioned Ansible, I've mentioned Terraform. I've also mentioned an Azure container instance that's coordinating a lot of this work. I've mentioned the GitHub repo. What you can actually see is the results of this release. Now, I'm not actually going to run this because this takes probably about 50 minutes or so to run. Here's one I actually ran the other week, and we can just look at what's happened. So here you can see the VM Image Builder create template. And in here, we can see the results of the log, and you can see that it successfully deployed that template. The next task it went on to run was create and distribute image. And I had the debug flag on, so just in case you couldn't figure out what was happening, you definitely can't figure that out now. And if we look right down at the end, pretty much nearly the penultimate line tells you that this has succeeded and created. So what I'm emphasizing here is I didn't just make this up. This is not staged. This is actually a real release pipeline that ran. So we had Image Builder there creating a template and then creating an image after that. Then we called Terraform init, and then lastly, we called Terraform apply. And Terraform apply, for those of you who know Terraform, essentially will take that Terraform configuration of the VNet, the IP addresses, and then it will start connecting to Azure and start building all that. And when you actually look in here, you can see it building the NSG, you can see it building some storage accounts, and so on and so on. Right down the end, what it's actually done is it's actually spat out the DNS name of my website. So if I now click on this, what you'll actually see is the website that was created. So I have as essentially 2 VMs that are running in a scale set, in a highly available deployment, and they're running this website. And you can definitely tell that it was me who created this and was messing around with this, because I can't spell Terraform. So now, if I actually look at what happened there, let's look on the back end. We can see the resource group that was created, and then on top of that, you can see some tags, and then down here you can see all the resources that were actually created as part of this deployment. And this is an example of an immutable infrastructure. I can simply just go and delete that resource group, rerun the release again, and it will just create it all over again. So it's just a small example there.
I mean, in this case, we were using basically Visual Studio Online, or we call it Azure DevOps now. But you could do this from Travis or Jenkins or whatever, because it's all just standard APIs and the CLIs are available.
Okay, so this was just a backup slide, just highlighting that some of the nuts and bolts that I've already gone through. So that was essentially a demonstration of how you could essentially build an immutable infrastructure, how you could integrate the Azure Image Builder into an existing CI/CD pipeline. But how could you actually integrate it into your existing release process? This is something that one of our first-party customers was interested in. Paul, would you like to talk about it?
Yeah, so what a lot of customers will want to do is basically create an image and then run some tests on that image, maybe even run it in a stage or a canary region or cluster first, and then promote it to production, kind of. And so this is kind of what we show on this slide. So this is basically the same pipeline as you saw now, only there are like 3 arrows going through it. The 3 arrows on the right side basically represent 3 different images in a shared image gallery, where you can basically say, we'll publish to testing first, and then, if that looks good, we can publish to pre-production, and then, if that looks good, we'll promote it to production. And that's kind of how you could do that. Yeah, I don't know. Is that all I wanted to say about that?
Yeah, that was it. It was just to highlight,
cool.
Look, yeah, you can essentially then, that's how you can slowly slip in your image into production and run, and you'd follow your safe deployment processes and so on and so on. So just the summary slide. Essentially what we've seen so far, we've seen the image builder. We've seen how you can create a custom image, literally with a template. You didn't have to configure anything. It was all just done for you. We also saw that it was a first-party scenarios that we have right this minute. Not in any order. We want to look to support Windows. How important is that to you? Just a show of hands, how many people would use Windows? Okay. It's convincing.
Yes.
Next one I mentioned, the ability to actually ingest an existing custom image. So if you've already gone through this cycle once, how can I add some more customizations to an existing image that's already out there? Next one, increasing support for Red Hat ISOs and Azure Linux Marketplace images. UI support, would people use UI support? Is that something of interest to you? A show of hands. Okay. And then lastly, CLI SDK support. What you've seen me use there is sort of very generic AZ CLI commands, just to reference the resource provider directly. A couple of other things that people have mentioned. What you saw in the customize phase, we've just got a shell customizer. Some people have mentioned that for Windows, they'd like to see a DSC customizer. Is that useful to people? Okay. And obviously, if we did this for Windows, instead of obviously a shell scripts, you'd take in PowerShell scripts. Another thing that was suggested to me yesterday was also an Ansible customizer as well. I can see some people nodding. Interested? Nice.
Maybe Chef. But a Chef. I'm Chef too.
Yeah. In terms of some other things that that was suggested to me, actually maybe having a repository of customization scripts, so you could actually just link, and we could have like some sort of shared repo of, I don't know, installing all different types of tools, and then people could go and fork them or do what they want with them. That was something somebody suggested. Another one was being able to support the ingestion of Kickstart files in the source for Red Hat images. Would that be useful for people? Okay. Okay, so these are some of the things that we're thinking about, and these are in our backlog. Obviously, we'd like to do these all immediately. We can't always do that. Is there anything that we haven't said here or that you think would be useful, or any feedback? Yeah, please. Yeah, sure, go for it. Yep. Okay. Okay, so the question was there, this gentleman didn't see a place where he could actually access his internal resources on his internal, on his subscription. Now, do you want to explain, Paul, how it works?
Yeah, so we definitely have that in our backlog somewhere as well. Like, it's a long backlog, but I'm sure it's in there. What we can do is when we invoke Packer to basically run your shell script, we can definitely instruct it to use your custom VNet, and that way you could actually access your custom scripts that you would use. We're still thinking exactly about the semantics when we create the image, because our resource provider might not have access to your VNet. I think even that we can make work. So we'll take a look at it, right?
So, yeah, so essentially for private preview right at this minute, when Image Builder actually creates the resources in the pipeline, it does that inside an Azure Compute internal subscription, and then the actual image template artifact, that's stored in your subscription. So like when you saw me dump out the artifacts in my resource group, you could see the image template artifact there, and you could see the images. As the image builder runs, even right now, you will not see any of the resources that it needs to create that image. That's because it's done in an Azure Compute-owned subscription. What we're looking at doing is essentially, which is what Paul mentioned, was having or giving you the ability to say, right, don't use an Azure subscription to create the image. Go and build all the Azure, or essentially build the Azure VM Image Builder pipeline, build it in your subscription. And that has some benefits. One is that it can access your artifacts inside your subscription and potentially on-premise. The other one is as well is that we obviously have to spin up VMs to make this all work, and resources. Now, we use quite small VMs. One thing we could actually light up is actually allow you to specify which VM or which VM sizes you use to run the customization. Obviously, we're using quite a small VM size at the moment whilst we're in preview. But what you could do is if you've got say an image customization that installs some really big application, you could actually increase, or you could actually be given the option to deploy a larger VM for the image customization and speed up the entire pipeline. So it has some advantages to it. Does that answer your question? And your second question? Okay, so I think the question is there. I want to use an existing image that you see in the Azure Marketplace, a vanilla image there. I want to run some customization on it potentially, and then I want to distribute that into my own shared image gallery or managed disk image. Is that correct? And yes. So if and when we open up the option to ingest a Red Hat premium, Red Hat image from the Azure Image Gallery, yes, it will still be a pay-as-you-go license. That will follow through. Okay, so this gentleman here would like to take an image out the Azure Marketplace and do something with it and then distribute that to Azure Stack. We don't have support for that. That's something I think we'd have to take away. There's some complexities there because there's obviously some billing mechanisms and licensing that we'd have to adhere to and make that work. But we can take that back as feedback. Thank you. Next person.
So if my image is more than 3 hours old, I want it to patch and reboot basically as part of the installation process. Can that be configured? How do I make sure that happens before it goes online and is available to the internet?
So, sorry, can you just repeat?
Basically just apply all the necessary patches from the time that the image was created. The auto update as part of the installation and configuration process.
So when the image is created, you want
after the image is created, when I install it on the in the VM and I create the VM, how do I get it to automatically update prior to going online?
I'm not sure how we could do that. What would be the best way? You'd have to have some almost like startup script that would.
Exactly. It would differ per distribution or whatever. I would say send Dan email and I make sure that he'll give you a good answer.
So essentially there, just to sort of phrase the question for the audience, essentially you've created an image using the Azure VM Image Builder, and then it could be maybe, I don't know, another 2 weeks before you actually boot a VM with that image, but there could have been some security patches that have been released by the time the image was created compared to when I actually boot a VM from that image. How can I get all my patches? There's maybe a couple of ways you could do that, and again, it depends on the distro. What you could do is, if the Linux image is provisioned using the Linux agent, so currently Red Hat is, you could actually tweak the configuration. So maybe it runs, you can pass in a command, so it starts and runs a custom command that goes and actually pulls down all the latest security patches. That's one way. Essentially for the canonical side of the house, you could use a cloud init configuration and say, right, go and update all the packages when you boot. That's potentially.
I mean, this is also a strong point for the Azure Image Builder service, because you could also just rerun your image template every 3 hours and basically get all of your updates in your image, so that when you boot, it's never more than 3 hours old, basically.
And you see, that's the beauty of the shared image gallery, because your version, essentially every time the image builder actually spits out an image, the version gets incremented. So when your customers or your internal groups actually go and deploy that VM, if they just do the AZ VM create command, and then instead of actually specifying a version, they specify latest, they'll always get the latest image. So that could build on top of Paul's solution there. Next one.
If I have a custom product, how to store the MSIs. Okay, so we have a repository of MSIs, various products stored in some place. So currently, what do you suggest if I have to use this thing? What do you suggest I should store? Like store in a VM, or can I store in AFS? I'll share. I can show all the.
So is the scenario that you want to use Azure VM Image Builder, you want to pull down some MSIs and then install those?
Yeah, so I need to store it somewhere where it can be accessible to the.
Okay.
So what do you suggest, like put it in a VM or support getting it from your file share.
Okay, so essentially the question is there, I want to use Azure VM Image Builder, but during the customize phase, I want to download some MSIs from somewhere. How does the Azure Image Builder actually get access to that, or how could it get access to that?
Yeah. So you're saying either host them in a VM that exposes a file share, or host them in...
Yes.
Yeah.
Okay.
Actually, I don't think we have a very specific opinion on that. Specifically, when we're going to implement Windows, these scenarios will come up, right? Because you want to install something. I think one of the things that currently is on our backlog that we also need to look at first is how do we get secrets into your build? And that might also require that we have access to things in your subscription. So we'll run stuff in your subscription, and the service will have an identity that can access a key vault or something like that.
Another thing is like Windows, we could also support libraries. If I have multiple versions of Windows, I'll be obviously having files and data across images. If you support multiple same.
Okay.
Yeah, well...
So the question was this gentleman asked us, when we look at supporting Windows, this gentleman could have multiple versions of essentially images that for Windows. Now, obviously, you're going to be paying for storage for each of those images. Essentially, could you save money by compressing these, or some sort of money saving or compression technique?
Yeah, I mean, we'll be working a lot with the case team to see how we can optimize the storage in the back end. Because obviously this whole image building is kind of layering one image on top of another, so there will be like a delta and stuff like that.
Yep. So we can look at degrouping. Whilst the shared image gallery guys are here, could you look at degrouping?
It's already done.
So apparently, the conversation was there that can we look at deduping? So instead of you paying for say 10 images that are only have only small deltas between them, can that be deduped? This is on the roadmap of the shared image gallery, and since there's a lot of us in the room, we've all heard they've said that's committed. Okay. Yeah. Anybody else? Another question or feedback? 10 minutes left. So for those of you who are interested in joining the private preview, we have a link here. We also have a related session at the bottom what time is it, Kay? Today at 4:30. And this is talking a bit more about VM scale sets and the shared image gallery. So obviously, if you've been using the image builder, you can integrate into that and utilize that too. So I hope you've sort of seen some of the things that we're working on and what we're thinking about. We appreciate your feedback. If any of you have any specific feedback you'd like to share with us, please just drop me an email. We're happy to listen. Like I say, this is very early on in the release. We're not finished or nowhere near finished yet, so we're happy to make a product that you want. Cool. So thank you very much, everybody.
Thank you.